Okay, in this video we're going to cover 7.3, which is complex numbers in the polar form. Alright, so complex number is going to be in a form of a plus bi, and it has two parts. The a part is a real part, so that's a real number on the number line. The bi part is your imaginary part, so the I tells us that it's an imaginary number. Okay, two axes are required. We're going to have our real axis, which will be the x-axis, and then the imaginary axis will be our y. Okay, so a complex number can be written as an ordered pair. Instead of using x and y, we'll be using a and b. So a will be the coefficient of the real number, and b will be the coefficient of the imaginary number. Okay, so let's go ahead and graph a few of these. Number 1, -1, -1, -5. 1, 2, 3, 4, 5. This will be number 1. I'm going to go ahead and label this as number 1. Okay. Number 2 is 3i. Since there's no real part, we would stay here at the 0, and then we would go up 3. 1, 2, 3. This is going to be number 2. And then number 3 is going to be a -4. And notice that this is a real number, not an imaginary number, so we're just going to go back 4. 1, 2, 3, 4. This will be number 3. If I were to write these out as an ordered pair, we would just basically say -1, -5, 0, 3, and -4, 0, since there's no real part. Okay, so the absolute value of a complex number is also called your magnitude. That's what I'll be using it, okay? Magnitude is identified like this, and it's going to be similar to finding the hypotenuse by using Pythagoras' identity. A is like your x, B is like your y, so we're just applying Pythagoras' identity. Let's go ahead and find the magnitude for number 4. We can say the magnitude of z is equal to the square root -7 squared plus -12 squared. Okay, so here it's going to equal to the square root 49 plus 144. Okay, let's use our calculator. You should get square root of 193. So the magnitude of z will be square root of 193. Okay. For number 5, we're going to find the magnitude of z again. 4 squared plus -6 squared. 16 plus 36, okay, is equal to the square root of 52. And if you remember, we need to simplify this, so I'm going to go ahead and do that. Square root of 52, I can say that is the same thing as 413. So if I take the square root of 52, I should be able to take the square root of those individually. Square root of 4 is 2, and the square root of 13 will be the same. So the magnitude for number 5 is going to be 2 square root of 13. On this side, we're going to be learning how to write polar form of complex numbers. So remember, polar form is going to be with your r and your theta. So we still have these equations that we have written here, where a is equal to r cosine theta, b is r sine theta. Pythagoras' identity can help us solve for r, the length of r, and then tangent is opposite over adjacent. Okay. Notice here you're going to be using radians or degrees. Now, this is how we're going to write it in polar form, but I don't necessarily write it all like this because theta is going to be the same for both. What I tend to do is use the shorthand. So this is saying cosine imaginary number sine of theta. Theta is going to be the same for both of these. Okay, so we can write it as r parentheses cosine theta plus I sine theta, or we can write it as r cis theta, because theta is going to be the same for both. Okay, all right. Here's an example. written like this, or it can be written like this. Okay. All right, let's go ahead and write the complex number in polar form. This is our A, this is our B. So I'm going to use this formula to solve for R. Okay. Square root negative square root of 2 over 2 squared plus negative square root of 2 over 2 squared. Let's go ahead and solve for this one. Negative times negative is positive, and then we're going to have 2 over 4, this is all square root, plus, again, 2 over 4. Now I'm going to add these two together, and I get 2 plus 2 is 4, so I get the square root of 1. So here, R is going to be equal to 1. Now I need to solve for theta. So remember, tangent of theta is equal to B over A. Opposite over adjacent. So we're going to start here. Negative square root of 2 over 2 divided by negative square root of 2 over 2. Okay, which all of this is just equal to 1. All right. So now what we need to do is find theta. I can say theta is equal to inverse tangent of 1. But wait, remember, we need to consider which quadrant we're in. If I look at the signs here, negative and negative, I should be in quadrant 3. Okay, so we need to make sure that our theta is in terms of quadrant 3. So let's see, where is tangent equal to 1 in quadrant 3? Tangent's equal to 1 right here, which means theta is going to be 5 pi over 4. Okay. So when I write my complete answer, I have R now and I have theta. I can put Z is equal to 1 CIS 5 pi over 4. And this will be your answer for number 6. Okay. Number 7. Same thing. Okay. First, let's find R. R is equal to the square root 12 squared plus 5 squared is equal to 144 plus 25, which is equal to 169. So R here will be equal to 13. Okay. Then I'm going to find theta. So tangent theta is equal to 5 over 12. Now remember, in this particular case, this is not on the unit circle, so we have no option but to go ahead and use the calculator. So I'm going to do theta is equal to inverse tangent of 5 over 12. Okay, let's go ahead and plug that in. Since we did radians in on number 6, let's go ahead and find this in degrees. Okay, so I made sure my calculator is in degree mode, and I'm going to do second tangent 5 divided by 12. Okay, theta would equal 22.6 degrees. Let's make sure our theta is in the correct quadrant. Well, A is positive, B is positive, we should be in quadrant 1, and 22.6 degrees is definitely in quadrant 1. So now I can go ahead and write our answer for number 7, and I'm going to say that Z is approximately, and I'm using approximations because this is an approximation, 13 CIS 22.6 degrees, and that will be our answer for number 7. Number 8. Okay, here's this form. Write it in rectangular form. So the only thing we're going to do is we're just going to actually evaluate this. So we're going to be using our unit circle, and we're going to say, what is cosine of 135? Cosine of 135 is negative square root of 2 over 2, and sine of 35 is the square root of 2 over 2. So all I'm going to do is evaluate. Negative square root of 2 over 2 plus I square root of 2 over 2. Okay. Next thing I'm going to do is go ahead and distribute the 6 to both sides. 6 can cancel out with the 2's, and I'm going to have negative 3 square root of 2 plus positive 3i square root of 2. These equations here are our products and quotients of two complex numbers in polar form. So if I wanted to multiply two polar form numbers together, I would use this equation. If I wanted to divide them, I would use this equation. These formulas, they are on the reference sheet right here and right here. So all we're going to do is use it. Okay. Let's start with number 9. Here it's giving us our first z, and then this is going to be the second z. It says multiply these two and write it in polar form. So all I'm going to do is use the formula. Here it says if I'm going to multiply it, I'm going to take r1 times r of 2. r of 1 times r of 2 is going to be 20 times 3, which is 60. CIS. And then here it says I'm going to add the two angles. So 30 plus 210 is going to be 240 degrees. Okay, you can leave your answer like this because it says to use it in polar form. So this will be our solution. Number 10 is giving us two new polar forms, and now it's saying to divide. So we're going to use that second formula. Now, if z1 is divided by z2, we're going to use r1 first. So r1 goes on top, which is 8. Over r2, which is 2. CIS. And then over here, we're subtracting the two angles. So I'm going to start with 7 pi over 12 minus pi over 4. Okay. So now I get an answer of 4 CIS, and then let's use the calculator to get the second part. So I'm going to do 7 divided by 12 minus 1 divided by 4. So that will be 1/3 pi, or pi over 3. Number 11, we have two new formulas, but this time it's not in polar form, it's in complex form, but it wants us to find the product and write it in polar form. So let's do this one. First thing I'm going to do is I have to change each of these into a polar form. So let's start finding r for z1. So I'm going to use it as r1. r1 is going to be equal to the square root 1/2 squared plus square root of 3 over 2 squared. Okay, this will be 1/4, this will be 3/4. So 1/4 plus 3/4 is the square root of 1, or just 1. Okay, then for theta, I'm going to use tangent theta is equal to, I'm just going to use the square root of 3, because remember the 2's will cancel out, so I'm going to say the square root of 3 over 1. Okay, so it's this part over this part. Theta is going to be in quadrant 1 because these two signs are both positive. So then what I can do is just use the unit circle to find out where is tangent equal to the square root of 3. And when I look on here, I can see tangent's equal to the square root of 3 at pi over 3. The second one I'm going to do is z2. So I'm going to look for r2. r2 is going to be equal to the square root 3/2 squared plus 1/2 squared. Notice it's essentially the same thing as I have up here, so my answer will be 1. Theta for the second form is going to be also in quadrant 1. So I can say that tangent theta is going to be equal to 1 over the square root of 3. Okay. Use the unit circle to find theta. Okay. Theta is going to be equal to pi over 6. So now what I'm going to do is use my formula. If I'm multiplying these, I'm going to be multiplying my r's together. So z1, z2 is going to be equal to 1 because 1 times 1 is just 1. I'm going to do my CIS, and then I'm going to add the two theta. So pi over 3 plus pi over 6. Okay, and I'm going to use my calculator to find what that is equal to. Plug it in, I get 0.5, so I can say that this is pi over 2. In this section, de Moivre's theorem is the part that most students have problems with. But as long as you're using the formula, which is stated here, it's just a matter of plugging it in. All right, so let's just go ahead and start, and then I'm going to show you as we go. We're going to compute this to the 4th power, and we're going to write the result in a plus bi form. So we're going to write it as a complex form. First thing I'm going to do is label everything. This is going to be my r, and this is my theta. Okay, so when I have it raised to a power, in this case n is going to be equal to 4, I can evaluate this. Instead of foiling it, I could use this formula just to go ahead and find the actual answer. So let's just plug it into this side. R raised to the nth, so in other words, this will be equal to 2 raised to the 4th. And then I'm going to do the CIS and then multiply n times theta. So I'm going to do CIS n, which is 4, times theta, which is 3 pi over 16. Okay, so now I'm going to go ahead and simplify this part. 2 raised to the 4th is going to be 16, so I'm going to have 16 CIS. 4 can go into 16 4 times, so this will be 3 pi over 4. Okay, now remember, this is polar form. We want rectangular form, so I'm going to have to evaluate. Okay, so this is going to be the same thing as saying 16 cosine of 3 pi over 4. Use your unit circle. Cosine of 3 pi over 4 is negative square root of 2 over 2 plus I sine of 3 pi over 4. Sine of 3 pi over 4 is square root of 2 over 2. So all I did from changing this was evaluate cosine of 3 pi over 4 and then sine of 3 pi over 4. Now I'm going to distribute the 16 into both parts, and 2 can go into 16 8 times, so I'm going to have negative 8 square root of 2 plus 8i square root of 2. Okay, and now all I've done is change it to rectangular form. There's my I. So this will be the answer for number 12. Number 13, the difference here between these two problems is this is in rectangular form, this is in polar form. In order for us to use this theorem, it needs to be in polar form. So the first thing I'm going to do is change this to polar form, and I need to find what my r is and what my theta is. So r is going to be equal to the square root of a squared, so 2 square root of 3 squared, plus b squared, which is 2 squared. This will become square root 4 times 3 plus 4. Okay, 12 plus 4 is 16, which means r is equal to 4. Okay, for our theta, I'm going to say tangent theta is equal to b, which is 2, over 2 square root of 3, or in other words, 1 over the square root of 3. I can use the unit circle to determine this, and remember, we're looking at our a and b as being positive and positive, so our theta has to be in quadrant 1. It doesn't say degrees or radians, so let's go ahead and find it in radians. So theta will be equal to 1 over the square root of 3 occurs at pi over 6. So theta will be equal to pi over 6. R is equal to 4. Theta is that, and my n will be equal to 6. So n is equal to 6. So let's just plug it into the formula, okay, this formula here. R raised to the nth, so 4 to the 6, CIS n theta. CIS n, which is 6, times theta, which is pi over 6. Okay, so now I'm going to go ahead and evaluate that. 4 to the 6th power is going to be 4,096. CIS, 6 cancel, so this is just pi. Okay. Go back and say, wait a minute, it doesn't want it in polar form, it wants it in rectangular form, in this complex form. So let's go ahead and evaluate. What is cosine of pi? So again, use your unit circle. Cosine of pi is -1 plus sine of pi. Sine of pi is just 0. So now we just distribute, and we're going to say this is going to be equal to -4,096. So what we're going to do now is find the nth root of complex numbers. This is a little bit harder to do. It's a little bit more involved, a little bit more work. So basically what we're going to do is find all the roots where if we applied it to a certain power, we would get all of the solutions. So this is a really complicated equation, but you do get this on your reference sheet, which is located here. This is going to be for radians, and this will be for degrees. Okay, so you do get them. I'm going to go ahead and start, and then you'll see what I mean by finding the fourth roots. Okay, so this is like saying x to the fourth is equal to 81. This is exactly the same thing. Normally what we would do here is we would say, oh yeah, I can take it to the fourth root on each side and say, what is the fourth root of 81? And I could say, oh, okay, it's going to be plus or minus 3. All right, but remember what the power says. The power says there could be 4 possible answers. Well, there are actually 4 answers. One of them will be positive 3 and the other one will be negative 3, but there's also 2 other answers that are correct as well. So let's go ahead and find those. I'll just be walking you through this one so you can kind of see what we're doing. So the first thing I'm going to do is I'm going to go ahead and graph this on a chart. So I'm going to go ahead and graph it over here. And remember, this is a real number, and my real number is here. So if I were to go to this line, I'm going to plot 81. 81 is going to be like right here. So if I have this line, what is R going to be? Well, if it's just one number, R is going to be 81. And if I plot it on my x-axis, you can hopefully see that theta is going to be 0 because it's on the x-axis. So all you're basically doing is plotting the point and then determining what your R is. Whenever it's on the real axis or the imaginary axis, R will be whatever the coefficient is. And theta will either be 0 degrees if it's here, 90 degrees if it's here, okay? It will be 180 degrees if it's here, or it will be 270 degrees if it's here, okay? In this particular case, we're going to be using radians, so I just put 0 with no degree sign, so it's 0 radians. Let's go ahead and plug in everything. N, in this case, is going to be equal to 4. That's going to be N. Okay. R is going to be 81, and theta is going to be 0. 81 to the fourth, CIS, 0, because that's theta, 2 pi k, divided by N, which is 4. The fourth root of 81 is going to be 3, so I'm going to use 3 CIS pi k divided by 2. Okay, and I just simplified it. Now for k, if you look at the formula, k will start at 0 and go all the way to n minus 1. So if n is 4, we're going to go from 0, 1, 2, and 3. So let's go ahead and start with k is equal to 0. If k is equal to 0, I'm going to have 3 CIS 0. Okay. What is cosine at 0? Well, use your unit circle. Cosine of 0 is just 1, so I'm going to have 3, 1, plus sine of 0 is going to be 0, I. Okay. When I evaluate this, I'm going to just distribute it in, and I'm going to get 3. Okay, k is equal to 1. We're going to have 3 CIS. K is equal to 1. I'm going to have pi over 2. Okay, so that's 3. Cosine of pi over 2 is going to be 0. Plus sine of pi over 2 is going to be positive 1. I. Distribute the 3. I'm going to get 3i. Okay, let's do k is equal to 2. 3 CIS. If k is equal to 2, the 2's will cancel out and I just have pi. And this will be 3. Cosine of pi is now negative 1. Plus sine of pi, which is going to be 0i. Okay, distribute it in, I get negative 3. Okay, and k is equal to 3 CIS, 3 pi over 2 from here. Just put in a 3 for the k, and then I'm going to get 3. Cosine of 3 pi over 2 is going to be 0, plus sine of 3 pi over 2 is negative 1, I. If I distribute this in, I get a negative 3i. Okay, so we can actually check these. I'm going to check the 3 and the negative 3, and all I'm going to do is raise that to the 4th power. So there's my 81. That's my first answer. I verified it. Let's check the negative 3. Now remember, negative 3, you have to put in a negative first. So I'm going to put the negative 3, and I'm going to raise that to the 4th power, and I also get 81. So these two are correct. I'm going to go ahead and look at these two, okay? Because these two you can't do on a calculator, but we can do it manually. I'm going to check 3i. Okay. So if I'm going to apply this to the 4th, and I'm going to apply this to the 4th, what I'm basically doing is saying 3 to the 4th, I to the 4th. Now 3 to the 4th we do know is 81, but what about I to the 4th? Well, if you went back into college algebra, remember we said I is equal to the square root of negative 1. I squared is equal to square root of negative 1 squared, and the square and the square root cancel, so it's just going to equal to negative 1. We said I to the 3rd was the same thing as saying I squared times I. Well, I squared is negative 1, so I can say negative I. Okay? And I to the 4th is the same thing as I squared times I squared, which is negative 1 times negative 1, which just equals a positive 1. So I to the 4th is just equal to a positive 1. So this actually works out as well. So this does come out to 81. Okay. The same thing would happen if we were to check negative 3i. So the negative to the 4th power is in other words, negative times negative times negative times negative. That is equal to a positive 3 to the 4th, I to the 4th, which is exactly the same thing we got here. So this will equal to 81. It will also work out. So here we actually have 4 solutions, and this will be your answer. Number 15 is a little bit harder. Here we're going to label everything. R is going to be equal to 8. Theta is equal to 204. And N will be equal to 3. I'm going to plug in my formula. The cubed root of 8 CIS theta, which is 204 degrees, plus 360 degrees times k divided by n, and n is going to be 3. Let's go ahead and let k is equal to 0 first, and just plug in our values. The cube root of 8 is the first thing I'm going to do in my calculator, and that comes out to 2. So this is going to be simplified to 2 EIS, and then I'm going to go ahead and leave it like it is. 204 plus 360 k divided by 3. All right, let's start with k is equal to 0. 2 CIS. If this is 0, we're going to do 204 divided by 3. I'm going to get 68 degrees. So I'm going to put CIS 68 degrees. K is equal to 1. I'm going to go ahead and plug that in. 2 CIS, and then let's plug the 1 into the formula. I get 204 plus 360 degrees. Add that first, and then divide by 3, 188. K is equal to 2. I'm going to have 2 CIS, and then plug in a 2 here. 204 plus 360 times 2 divided by 3. You're going to get 308. And because it says to keep it in polar form, I'm not going to evaluate it into a complex form. I'm going to keep it in terms of r and theta. So these are going to be my 3 roots. That concludes 7.3. If you have any questions, just let me know.